Okay, and the stream should have started. Okay, then I think it's time to call you welcome. Welcome to the second session of the 2025 J Champions Conference. For this talk, we have two presenters for you. They are both developer advocates at Red Hat, contributing to open source projects, and they are developing for the cloud. And thanks to this being a virtual event, we have on the one side Daniel O, live from the United States, and on the other side of the Atlantic Ocean in beautiful Belgium. And yes, I can know that. We have Kevin Dubois, and they bring to you serverless Java in action, cloud-agnostic design patterns and tips. They will show you how to create a production-grade, cloud-agnostic, event-driven serverless solution with Quarkus on Kubernetes. If you have any questions during the presentation, please ask them in the chat. I will collect them and we will handle them at the end of the presentation. So far for the introduction, I think the floor is yours, Daniel and Kevin. I will remove myself from the video and up to you.
Thank you so much, Frank, and hello everybody, and then thanks for joining in the early morning or even a little bit late in the afternoon, depending on where you are. And then my name is Daniel, and here's my colleague, Kevin DeBoer. So we're going to start, and I'm going to share my screen first, and then we're going to talk a little bit ourselves real quick. Let me share my screen. There we go. Slideshow. All righty. Once again, so as Frank mentioned, I'm from Boston, United States. That's why I consider in the this beautiful the Boston downtown area. And the Kevin, here we go. And then he's based on Brussels, and then here's another beautiful city in the Europe country. And then that's why we put under these two great photo at the beginning of this intro slide. And then we're going to talk a little bit about serverless Java in action, more cloud agnostic design pattern and tips. Once again, my name is Daniel O from Red Hat, developer advocate, and here's my contact info. And then I'm also CNCP ambassador for a long time to give some more opportunity and then find more engagement with a lot of developers and the platform engineer, even AI engineer and so on. And Kevin, there we go. You're going to talk a little bit about yourself.
Oh, man, I have to talk about myself. So, yeah, I don't mind. I'm Kevin. I'm based in Belgium. I'm also Java champion, just like Daniel, and just like Frank, and just like everybody on this conference, I think. Yeah, so I'm a developer advocate at Red Hat. My background is in software engineering. I'm, of course, a big fan of Java. And but I kind of moved somewhere between Java and the platform engineering. So, you know, that's also what this talk is about a little bit. We're going to talk about Java and also a little bit about, you know, how can we get our Java applications into, you know, a production platform, in this case, serverless. So on to you, Dan.
Yeah, thanks. Yes, inevitable. So we have to always like a conversation with the platform engineer too, whenever we talk about application stuff. So I'm gonna just start with take a look at a really bit interesting survey from CNCF or another like some blog post or survey stuff. So why people really thinking about the serverless, and then you can see that some of the factor reading you and your company spend a lot of money and more money for that. For example, here over provisioning. So basically, and traditionally, you have to figure out how do you increase your resources, and for example, scale up and down based on your seasonality workload. We have a big, for example, like a Black Friday, and how to handle the spike workload during that event. You're gonna buy more like a CPU, memory, and hardware, and even like some more web server, application server, and so on for like a scalability. But after that, the workloads pretty much decrease, but you cannot get rid of all already by the resources. So that's kind of a provisioning issue, sometimes under provisioning as well. And then whenever you don't need to that increase the resources, and then you don't have maybe a proper way to deactivate it when their resources are not using. So this all kind of problem, and then if you don't have on-demand resource scalability at a time based on your traditional hardware and software infrastructure, and then architecture as well. So that's the reason why Serverless has came out and unleashed upon the world. We're gonna really talk about a little bit the historical, the time frame when Serverless actually came out, and then how to evolving so far. So for that, Serverless, some people are actually, oh, there is no Serverless, but that's not true. There are actually a lot of server. But the point is, Serverless, someone actually take care of your infrastructure when you run and deploy your application. So this is just some kind of deployment model or a development model, how to build and deploy your application on the cloud without any management of infrastructure. So this is a traditional deployment of what kind of potential is you probably have buffer without Serverless. So for example, this is just some your requests between like a 15K and the 220K requests. And then so your request actually fluctuated, but your capacity will be like a fixed that. And then with that, sometimes you have under provision compared to your request, and then sometimes the over provisions. Under provision is a more issue because over provision, you still have a good enough resources to take care of your application workload. However, when you have under provision, your end user faces some latency or some white screen or some very slow response when you access some of the page. When you customer try to buy some important AirPod or some of the product, it takes more about 10 seconds or 20 seconds to get a response and finish the order stuff. So that's why Serverless came out and solved this kind of problem. And as you can see, exactly the same ratio between capacity and the actual end user request. And the more important thing is when you don't have any incoming network traffic or requests anymore, it hibernate and the resources go down like a zero. So you don't need to spend money and effort and any kind of resources for incoming network traffic as well. And this is a little bit more.
Daniel, just to kind of add to that. So with serverless, you can scale to zero depending on the serverless platform that you have, but you don't have to, right? So if you have workloads that maybe start up a little bit slower or something, you can also configure it based on the platform, whether you scale down to zero. So that is an option that you have in serverless, but that's an option that you typically don't have in other platforms.
That's great catch. Thanks, Kevin. And then really talk about like a cloud and a Kubernetes environment. As you can see, there are a lot of known workers in the Kubernetes. And then because inevitably you have to deploy your application to cloud in the more scalability and flexibility and so on. And then most cloud environment based on Kubernetes for container and so on. And then as you can see, left-hand side, you have many applications here. We just put the example Java with the Quarkus. And then there are many unused resources for utilization perspective. However, when you have a serverless, excuse me, so you can see that the right-hand side, you literally have the fitted in workload, and then sorry about that. And the serverless workload, your application job done is just go away, and the resource is return. And then whenever you have a new serverless workload, and then you put in the resources, so you definitely are more efficient and cost saving, and then it really be more impact like a low carbon the emission as well. It's a lot of company really consider about the ecosystem and then the environment, the reservation as well. And then there are some good Datadog survey result, and then the serverless adoption is to keep rapid increasement, not only from public cloud provider like a Big3, Amazon, Google Cloud, and Azure, but also a lot of on-prem cloud services or some other like a startup or since a project, they give you some more serverless capability. Even if you are concerned about AI workload, you can actually stand up AI workload, for example, serving runtime to run your LLM model, but also like how to service that LLM model using inference services. You can probably run as serverless. And then Kevin will really talk about at the end of a presentation what are the use cases, how to integrate serverless with the AI capability as well. So this is just some I mentioned earlier. So this is just serverless journey. Some people, no one actually care about serverless anymore, but that's not true. So serverless still keep ongoing and evolving technology. And then so we want to encourage people why need to consider about serverless your next generation architecture or cloud native architecture. So back in 2014 November, so Amazon Lambda unleashed upon the world. At a time, Amazon Lambda provide a few capability as serverless, for example, like a really big function only and the limited runtime because it's super expensive to run long time running process. And then, as you can see, as Java developer, the Amazon provides some SDK and API, how to develop, how to deploy your Java application into Amazon Lambda as a serverless. As you can see, there are some library and then package stuff you have to import to implement your like HTTP request response, the application on Amazon Lambda stuff. And then here is some highlight. This is one thing as Java developer to consider to develop serverless function on Amazon Lambda. But there are some more challenges when you adopt serverless, because you're going to approach to adopt serverless with a really good beneficiary we already mentioned about earlier, like no over provisioning, no under provisioning, on provisioning, and more efficiency and the cost saving and so on. But enterprise companies, they change a lot of stuff. For example, they change regulatory, which means that we cannot access some of the Amazon Lambda environment, some specific available zone in the Europe area or some like APAC, China stuff. And then if some global outage happen and then all application is just shutting down, you remember that like last summer, there are some, the Azure, like a CrowdStrike, and then some, so Kevin and I, we actually staying in, we are developer in Berlin as a part of the conference. We actually stuck in there because most flight actually canceled and delayed. So the global outage sometimes happen, and then the privacy change, and then there are a lot of some potential challenges you can have, even if you consider one dedicated vendor serverless. So, and then for Java developer standpoint, you still are locking some of the stuff. Okay, I already developed my business application, which should be running on somewhere Amazon Lambda as a serverless function. And now we're going to consider about another serverless platform, which is like a Kubernetes or some Azure or even Google Cloud. And then how do we change the application? But the application function capability exactly same. But there are locking technology and functionality which give more challenge for Java developer. That's exactly, we need to write in our application, Java application, more cloud agnostic functions. So let me give some example. How do we create a cloud agnostic Java serverless function with the Quarkus? Just in case, if you never have ever Quarkus, or even if you heard about Quarkus before, but never have a chance to a little bit hands-on experience due to some lack of time, or your company don't know how to you adopt Quarkus in your daily job, like a more opinionated Spring framework or any other reason. I'm going to just keep you reminding a little bit brief explanation of the Quarkus. So Quarkus is we could say Supersonic Subatomic Java, because Quarkus allows Java developer to have very small and then really fast, and then the application runtime, and then a lot of developer productivity functionality. So this is a more like a performance standpoint. With the Quarkus, you have a very small memory footprint, even if without native compilation, like a GraalVM stuff, and compared to traditional Java application. And then with the native compilation, and then you have a super fast, like a startup time, like as you can see, like a 16 millisecond, and the less than like a 12 megabyte, like just the memory footprint. But depends on what business logic you have. You have a very complex application to connect to multiple database, multiple messaging broker, and same one single jar, and then which is probably slower than these numbers. And then
Daniel, maybe to add a little bit of context why this is important, the startup time and the memory footprint, especially for serverless, is because especially when you want to have applications that are very responsive, like we want in serverless, we want to scale up when there's a lot of requests and scale down when there's few requests or to zero. But that also means that we have to have applications that start up fast because they need to react quickly, right? And then in terms of the memory, a lot of the cloud providers who provide a serverless serving like functions as a service platform, they charge also based on the actual usage of the application, right? So if we have a smaller footprint, we're going to be paying less. And if we start up fast, well, our users are going to be happier, and our runtime is going to be shorter, right? So we also save money in that way. So that's also very important.
Yeah, excellent. Yeah, that's a really good point, Kevin. Yeah, so it's a bigger, it takes some more time, as well as you spend more money, so networking, storage, and so on in the serverless platform. All right. So, and then Quarkus actually provide a lot of extension for Java developer to implement a serverless function across the serverless platform, like Amazon Lambda, Google function, and Azure function, and even Kubernetes, Knative, and so on. But the one of the good, interesting part of Quarkus to implement the serverless function with the Java. So, okay, so your company A, we are developing new Java function into Amazon Lambda at this moment. And then 6 months later, hey, we need to scale this serverless function to Azure because we scale new business branch in somewhere Europe, which we're going to use and contract with Azure rather than Amazon, like some pricing issue, or some of the availability and so on. In that case, so your CIO asks Java developer to, hey, so get ready to deploy this application into Azure cloud rather than Amazon Lambda. And then, as you can see at the very first, so we already using the Amazon some own dependency or library SDK. So I need to run something around Azure SDK once again, but my business application is exactly the same. So we're going to get rid of that change from Java developer with the Quarkus. That's exactly Quarkus Funqy extension allows Java developer to have a more portable API for implement function application across multiple serverless platforms such as Amazon Lambda, Google, and Microsoft Azure, and then like a Knative Kubernetes serverless function as well. So pretty much easier. You can see that we're going to import the Quarkus Funqy, and then you can put in the annotation on the method level or class level as a func annotation, which make your function and your Java class as a serverless function. So you can also have more event-driven serverless with the cloud event, which is one of the CNCF project, more standard like a messaging format across multiple different platforms to communicate a messaging for serverless as well. So you can also create a Quarkus project at the very beginning with the serverless, with some specific serverless platform. Amazon, just like a Quarkus CLI, Quarkus creates application, my function name, and the -x, which extension you're going to create it, like a Funqy with the Amazon Lambda, and so on. So let me jump into the demo. how that works and then what that looks like. Is there any questions so far?
Doesn't look like it. Just
Okay, cool.
Oh, there's a question from Eric. I hear there's a book in the works, and yes, so we are working on a book, serverless Java in action. And if Daniel, if you want to share your screen again of the slides, in the previous slide there was actually a link.
I actually removed that.
No, because we removed the slides. But if you go back to the previous slide that you were showing just before the demo slide, there was a link to the Git repo where we're putting the examples of what we're working on. We can share the link to it. Doesn't matter. Yeah. Anyway, yes, we are.
This one. Yeah, this one.
That's the one. Yeah. I can copy and paste it in the chat too.
Okay, that's cool. Thanks for bringing it up, Eric. Okay. Alrighty. And then, so here's this is actually the example Quarkus application Kevin and I rewrote during the book stuff. And you can actually access the Git repo and you can find this all example. So this example is a Quarkus Funqy, and then we have 3 projects. I already made that. 1 project deploying to Amazon, and 1 project for Azure, and 1 project to Google Cloud, GCP stuff. And then its application is pretty much simple. And then you can go to POM XML. It's pretty much simple. The race Quarkus 3.17a we released just yesterday. And then the Quarkus minor release happen almost every 2 weeks, something like that. And then go to dependency, you can see the Funqy extension here, like a Funqy, and then Funqy Azure, which automatically generate like a skeleton or stub Java classes for deploy Azure or Amazon or Google for this example. So you don't need to run something around the specific SDK or API or some command line for that specific serverless platform. And then go to application Java class. It's pretty much simple. This is a Java bean, so just define like a JSON format, this is we actually have some idea how do we create some serverless in the future, like an industry, like some planning and like a spaceship company. So that's why we print the Java bean with some actually the planning or some other stuff. And then actual Java function, you can see that pretty much simple, like just a font annotation, and then with the endpoint, and then just enter, just return, approve the rendering on planning, some like a Venus or Lisa, whatever we call that. So exactly same thing when you go back to even Azure, the Amazon. The only different thing is you can just import the relevant Funqy dependency here, like a Funqy Amazon, and then the others is exactly same thing. And I go to the application stuff, and then Java bean, exactly same thing, and the request function, exactly same thing. And there's no rocking for like a Amazon, some library here. You can only find the Funqy, and then the exactly same thing. So let me try to open the terminal. I'm going to quick check my application function working on my local environment, which is Quarkus demo. Is to give some live code, and which is really awesome to verify as a part of your in-loop process. So once the Quarkus is running, and then I'm going to open a new terminal, and then I'm going to check the let's go to check this one. So you can see that just called endpoint the REST API with some here JSON format planning name is Risa, and then you can really see that approval landing from planning Risa. So exactly, I just confirm my application, pretty simple serverless application working, and then I'm going to do the same thing all the other project, the Amazon, which is the same thing. And then once the Quarkus application runs, and then I can just call the same endpoint, and then you can see that approve landing planning Lisa. And then let me try to, you can actually run 3 applications simultaneously. When you export port, it's differently. Basic the port of the Quarkus demo is 8080. And then that's why I stop it and then start again, a different project. And then I'm going to try it one more time, and then you can see that resign. I'm going to change it actually planning name, something like Earth, and then you can see that it's the Earth. You can see that. So I just quickly check a simple Quarkus function across multiple serverless platform locally, and then I'm going to deploy this application, deploy to the multiple serverless platform. So this is my Azure account, and you can see that. Hopefully everybody see that. I'm going to refresh, and the Azure function, there's nothing in there. And Amazon Lambda, I'm going to refresh that. So there's nothing in there. And the Google function, refresh that. I'm going to nothing, it's just totally empty. And then go back to here. Let me try to deploy Azure first. So Quarkus deploy, which is a really convenient way. Quarkus CLI, you don't need to actually remember any edgy command line to deploy application. If you have any experience deploy any Java or even JavaScript deploy Azure function, you have to understand and learn how to use edgy command line. And then in the meantime, let's go to Amazon too. So Amazon, you can actually build the Quarkus application, and it automatically generate some magic bash script under the target directory, which is something like here, manage script. It wrapping all Amazon command line, like AWS command line, which also allows the developer doesn't need to understand, even remember all command line to deploy or update, even delete the Amazon Lambda function. So I'm going to create to just using manage script and create my Amazon Lambda. And the one last thing is the Google function. It added, we still working on Google Cloud, the command line integration still. So that's why in the meantime, we just need to use this Google Cloud command line to deploy my local application and build and deploy Google Cloud. So let's go back to Azure, and then it's still deploy. It will take some time, and then go to Azure. So now we have Azure, and then it will soon enough finish that, and then we're gonna call this domain name and then like a fully qualified domain name to access the my function. And then let's go to Azure, and then you can see that. So our application is already deployed, and then go to Amazon Lambda, and I'm gonna refresh my Amazon Lambda, and then you can see that Amazon Lambda Quarkus function is actually deployed. You can literally testing Amazon Lambda function in the web UI from Amazon Lambda. And let me try to this Quarkus AWS Lambda function, and then just plan it, and then like a Lisa, and I'm going to just delete that, and then go to test. And then it takes some time, and then you really got the same result, just like you have a local environment. And then let's go to function, and for Google Cloud, and the Google Cloud function is just deploy. Here you can find all kind of stuff. And then let me try to call the call command for Azure Cloud here. Where is the Azure Cloud? Here. Okay, let's go here. And then you can see that you got the same result from the landing Lisa. And then Google Cloud also same thing is that where is Google Cloud? And then I actually put in my call command here. And then you can see we will see the same result, the planning on Lisa. So key point from here, my demo, I'm gonna wrap it up. So in the Java developer standpoint, you literally have the same business logic, and without any specific SDK or dependency for your serverless platform, which you're going to targeting for deployment. And in the meantime, you just deploy application using Quarkus CLI or a little bit some of the cloud command line, which is pretty much easier. So which means the developer, you don't need to migrate or change any kind of application source code to deploy multiple serverless platform, which allows you have a cloud-agnostic serverless function with Java based on Quarkus. So now I'm going to hand it over to Kevin to more talk about advanced use cases.
All right, thank you, Daniel. So far we've seen how we can work with functions, which is great. Especially like if we use something like Quarkus and Quarkus Funqy, we're able to make our functions more cloud agnostic. The downside with the kind of the serverless functions is that we still end up with a little bit of a lock-in situation, because outside of your function, you're still tied into specific dependencies that are part of the platform, right? So here in this case, in the slide, you can see, for example, for AWS, this is like a survey or from Datadog, where they ask, what are you using together with your AWS, with your Amazon functions? And you can see, for example, API gateway, because to actually expose your functions, you need an API gateway, or perhaps, some sort of messaging system, SQS or Event Bridge. And so, but by using those proprietary services from within the cloud provider, which, they work great, but we are, again, kind of locking ourselves into these particular providers, right? So the serverless community has kind of evolved. Functions is really cool, and it's really handy to, especially for small workloads, to package them up quickly and get them into a cloud. But perhaps we can take this concept a little bit further into the container world, where we can then package our applications in kind of a standard way, no matter what programming language we're using. Preferably still Java, but we can also expand. We can deploy it kind of in many different ways with containers, right? Because there's different platforms. There are serverless container platforms such as Fargate and Cloud Run, and container instances from the different cloud providers that we just saw. But it also expands to, let's say Kubernetes, where we can deploy the applications kind of anywhere, because in theory, at least, you can run Kubernetes in your local data center on your laptop. Probably don't want to, but you could, or, in one of those cloud providers, but it gives you a lot more flexibility, right? So there are some solutions for that too. And that also allows us to expand the serverless concept to more than just functions, right? Because now we can use more like microservice style applications as serverless, get the advantages of the auto scaling and the potential scale to zero, and the ease of deployment. So again, the cloud providers, they are happy to provide a solution for containers too, right? Serverless containers, and basically you give a container and they deploy it for you, auto scale it for you, which is pretty good. In the previous example, we showed something with AWS, so we figured it was fair to show something with Azure this time. And you can see here kind of some screenshots of proposed architecture with using serverless containers for them with Azure container instances. But again, you see there are dependencies, right? So we have the Azure Application Gateway Service, and then we need maybe application insights and metrics that are specific to this cloud provider, or we want to use maybe some batch system or whatever, which could be interesting for serverless, right? Because it only gets called a couple times, so you scale up, you handle the request, and then you scale back down. But we end up with using external services again, and kind of get locked in again, because now we need to find equivalent services for a different cloud provider, or like if we want to do it on our local machine, we have to find something else as well. So like I was saying, Kubernetes offers some interesting solutions, and with Kubernetes, we can kind of expand, to anywhere we want to go. And there's a serverless kind of serving way to use Kubernetes, which is called Knative. So Knative allows you to use those same kind of serverless constructs of scaling to zero automatically and auto scaling based on requests kind of out of the box. So Knative makes using containers a lot easier because it has a way to deploy containers. Even for Java, you basically provide Knative with your sources, and it's able to package that up using a project called Buildpacks, and then deploy it to your Kubernetes cluster automatically, including the auto scaling and all that good stuff. It also has different capabilities that are maybe a little bit more out of scope of this talk, like revisioning and different kinds of solutions. But we'll go into Knative a little bit more. So here you can see a few different ways that you can use the Knative CLI. You don't have to use the CLI. You can also use, there are plugins for IDEs. You can use it. There's UIs in some Kubernetes providers as well to use just the UI as well. But in this case, I just want to show a couple different ways that you can use it. So the first one you can see here, kn-func create. Which creates a function, and you can specify the language, and in this case Quarkus, but it could also be Spring, or it could be Go or Python. So it expands to different languages, scaffolds the code for you, and then you give it the name of a function, and so it creates a function for you with some opinionated code already in it, and then of course you can go ahead and modify it the way you want to, and it could be modified to, for example, the what Dan was showing with the planet details and the planet landing requests. And then you can deploy your function with kn-func deploy, and that deploys your function. So really it can be as simple as that, and again getting all those things from serverless kind of out of the box. If you want to create a serverless service from a container that you already have, from an application that you already have, or you have a favorite way of building your container, then you can just, for example, deploy with kn service create, name of your service, and then -- image, obviously pointing to an image that you have somewhere in a registry. So there's different ways of deploying your containers. So
Kevin, there's one thing I want to add on kn-func, which is really helpful for developers. Like kn-func not only create and deploy, but also you can actually invoke that function as long as you have an endpoint. Even if a cloud event format, you don't need to remember all the syntax and the format stuff. You just invoke using kn-func, invoke some endpoint, which is just so convenient when you verify your function after you deploy your function into Kubernetes Knative. Yeah,
exactly. So we've evolved kind of from, let's say, functions to serverless containers. And then the serverless movement was like, well, this is really cool. We can scale based on demand. But most of the time, this is based on certain events that are happening, right? So let's tie in more of advanced use cases where we can leverage events, where we can also create workflow logics. You might have seen that with some of the cloud providers as well, where you can create different components and you can orchestrate them with a nice UI to call one service to another service, and then automatically have the auto scaling built in as well. So there are many kind of more advanced, let's say, usages of serverless as well. So that's all possible, of course, with Knative. Otherwise, we wouldn't be talking about it today. Here you can see kind of the main components of Knative. On the left side here, you can see we have the serving component where we create services that auto scale, that automatically also expose services with an ingress endpoint, which is kind of nice if you're familiar with Kubernetes and you're messing with how to actually expose your container to the outside world with ingress. It's a little bit complicated. Knative does that automatically for you. But then on the right side, you see kind of the eventing part of Knative as well, with sources, brokers, and triggers. So that's a pretty interesting component of this open source project as well. So you can see that you can have multiple sources go to a Knative broker, which will then forward those events to different consumers. So if you're familiar with kind of messaging systems and event-driven architectures, this should be pretty familiar with you. But in this case, it's really kind of cloud native and based on that serverless paradigm where your service is going to scale automatically based on how many events are coming in or not, and then scale back down. So Knative leverages another open source project, which is called Cloud Events. And Cloud Events is basically a way to make the messaging kind of more agnostic as well, because you probably know some messaging systems, they usually have their own kind of protocol or their own kind of way of working. So Cloud Events is trying to make that, kind of abstracted away, so you can send messages in the format of Cloud Events, and then you can have different messaging systems kind of receive those events. And Knative also speaks let's say the Cloud Events language with the Cloud Events protocol, and then you can send messages. If you're familiar with HTTP, probably MQP or MQTT or more message specific, you can use them all in with Cloud Events. So your application actually doesn't know about what the protocol is of the messaging system that you're trying to talk to. So here's an example, a very simple usage pattern of Knative eventing. So you can see there's an event, and then our service that we deployed, it could be a function or it could be a regular microservice that's served by Knative, is going to receive that event and then scale accordingly. But it can be a little more advanced too, right? So you can see here we have an event source that goes through a Knative channel. So this is also part of the, let's say, the Knative toolbox deployed on Kubernetes, which is going to receive those events, and then different services can subscribe to that channel to receive those events. And then you also have the concept of a Knative broker, which again, systems can subscribe to, but you can also filter which events go to which subscriber, and so you have a little more control over the events that are happening. So this is all Kubernetes native. So these are Kubernetes custom resources that handle this. So this is all kind of very cloud agnostic, because you can deploy this anywhere you want as long as your system is able to run a Kubernetes cluster. So let's maybe see this in a little demo, and maybe it'd be fun to if you would play along, and you can pick your favorite IDE. So I created this little demo, kind of over-engineered it, because I mean that's what we do for demos, right? With different services that are going to handle the requests coming in and then forward them. So here you can kind of see high level the architecture. So we have the UI part here that you're going to see once I show the QR code. And then, once you go to this UI, the service behind it is going to kind of wake up. Right now it's sleeping because nobody has the URL yet. And then once it wakes up, once you start hitting the endpoint, it's going to wake up and start scaling up services based on how many users there are. And then once you start selecting your favorite IDE, and you can vote as many times as you want, because we want to see this kind of scale up, all these events are going to be sent to an ingester service, which is going to forward the events to, in this case, a Kafka topic. And then we're going to have another service here that's going to slowly ingest those messages and then put them into a data or update a database. And then eventually in the UI, we'll see how many people are voting for which IDE. Yeah, no NetBeans. Sorry, Johan. I guess you can select other in this case, or Emacs, or I don't know what other things there are. All right, so I'm going to share the QR code. And well, actually, before I do that, I want to show you how this works on my cluster. So I'm going to go here. This happens to be OpenShift, which is an implementation of Kubernetes. But the nice thing is that I have Knative deployed here. And we have different services here, right? So we have these KSVC, so that's a Knative service. So we have the UI here. And you can see here that circle is white, which means that there are no pods running. So there are no resources running right now. It's just waiting for somebody to start going to this application. And then we also have the ingester with 0. And then the processor that receives the messages from my Kafka topic actually does have a pod running. So I wanted to kind of show how you don't have to have everything scale down to 0. And that potentially can scale to many. In this case, I just have one pod that's slowly going to consume all the messages. And by slowly, it's still going to be pretty fast, but it's going to be just one pod consuming. And then you can see here we have, of course, the database. And in this case, Kafka running in one pod. So hopefully it can handle all the requests that you're about to send. So hopefully you're not taking my whole system down. We'll see. Challenge accepted for somebody, maybe. All right, so I just want to show you, if I go to the URL here, this is going to wake up. So I'm going to click it here. I'm going to go back to the cluster, and you can see here circles coming up and the pods are running. And sure enough, we can see here that we already have, well, OpenShift dev spaces with 1,000 votes, because I was testing earlier. So I guess you can start voting in a minute when I share the QR code, and then you can try to beat that. All right, so I'm going to go back to the slides, if I can find them right here, and share the QR code. And then if you scan it, you'll just go to that same URL that I was just showing you, and then you can start voting. And I can maybe we can share it in the chat as well, the URL. I'll just leave this here for a minute so you can start voting. And then let's see, I'll put this to the side, and then we can start seeing if there are votes coming in. So we can see that IntelliJ is starting to get some love, and Eclipse too. Vim, so far, no love for Vim. VS Code, also very little. And in the meantime, I'll show you here, everything is, these pods are starting to scale, right? So we can see here, the UI created some pods, and you can also see that some of them are terminating, because once you go to the UI, then you're just hitting that one, so it knows that there's not as many requests anymore. So I'm going to go to sleep, and maybe some more people are hitting it, and then it's going to come back alive. Whereas the ingester pod here right now has one pod, but if you start hitting this URL really fast, you start voting a lot at least, we might be able to see this scale. So go ahead and vote a lot, and let's see if some more pods are being created. So IntelliJ people, do your thing. And in the meantime, I'll share the URL in our private chat.
I just shared. Share that.
Okay.
Yeah, and then Franco will share that. Yeah.
Okay, excellent. So let's see if this is going to scale, and if not, I can also cheat and go to my source code here. So in this case, this is what's actually happening, right? So this is just, in this case, it's a camel route, but it could be any Java code or anything, any other language. So it's just packaged as a regular container that is then deployed by Knative. So you can see here is the custom resources for Knative. You can see it's a serving Knative, and then we supply what container it needs to deploy. We set how much utilization before scaling up and stuff like that, which is probably a little overkill for this session. I'm just going to send a bunch of requests with my little cheater script here. And I'll show it real quick here. So this gets the service name, and then it's going to just use Hey to send 1,000 requests with a concurrency of 200. So of course I need to go back to my my Kubernetes cluster here, and you can see 13 pods were created. So it's handling all that load, and I just sent that in a big burst. And then after it's done handling that, you can see terminating because all those pods are going back to sleep. So we scaled up real quick to handle all those requests and then scale back down once those requests are gone. So we can see here the voting is continuing. IntelliJ is slowly but surely taking the lead, as I would expect from a Java crowd. So well done here. And you can keep voting, and we'll come back to this in a minute if you want. In the meantime, I'm going to go back to the slides.
Hey, Kevin, just one thing. So did you actually deploy Quarkus as a native mode or just JVM?
I did deploy this as native binaries. Yeah. So they start up very quick, and then, or even quicker than running on the JVM. That also makes the containers a lot smaller, right? So what I did is basically do a Quarkus build dash native. And actually what I did was Quarkus image build dash native, which creates the container image and then also does a native compilation. So you can see that happening here. You can see, well, it's downloading some dependencies, and it says cannot find native image because I don't have GraalVM on my local machine. Notices that and then runs it in a container. So it starts up a container to build my application, and then it's going to be compiled to a native binary in a minute or so. And fortunately, I have a little bit of memory on this machine, so it shouldn't be too long. But in the meantime, I think we can go back to the slides, and then Dan, you're going to need to remind me to come back to this, okay?
Yeah. So yeah, definitely. So this is really awesome. This is exactly Kevin mentioned earlier. So Quarkus a native compilation, which is really fast, the startup time. So as you can see, even if Kevin put in the 1,000 workload, you can see that it's a super fast scale up.
Yeah.
Mad clicking. Yeah, exactly.
So there, let's see how the votes are going. Yeah, IntelliJ is doing really. I'm surprised nobody has scripted something yet. Maybe somebody will be motivated.
Yeah.
Anyway,
everybody obsessed with IntelliJ.
Yeah, exactly. So that's how kind of serverless works in terms of serving, how you can tie eventing into your serverless as well. There are some more capabilities with serverless in terms of using serverless logic as well, which is a newer feature in Knative, where you can orchestrate different services with Knative to call one service and then the other, and then maybe from there call another service. So you can have maybe a more businessy kind of approach to handling your services as well. And again, they will auto scale and can be auto deployed based on how you orchestrate them with serverless logic as well. Then, of course, no talk these days is complete without talking about AI.
Inevitably, we have to.
Of course, yeah. And so the Knative project in itself also contributes components to the AI world. So, of course, having models served in a serverless way is also an interesting use case. So you only use the serverless model when you need it, right? You can scale up and down, which is also interesting for a lot of organizations that want to optimize using their models. And then on the right side, because of course we are Java developers, so maybe we should talk more about Java. We can see here, this is kind of a newer feature with in the AI world, which is Model Context Protocol, which is basically like calling remote services, if you will, from an LLM. So in this case, you can see we give some capabilities to an LLM to get weather alerts for a US state and then get weather forecasts for a location. And this is a really interesting use case, right? Where LLMs call these services, and why not serve them as serverless workloads as well? Because we don't know when exactly LLMs are going to call our tools, our remote services, and we don't know how many times. So if we serve them as serverless, that makes a lot of sense. And we can use Quarkus for that. So this is a very new feature. So it's a little bit experimental, but you can read more about it in this blog post on the Quarkus website.
Yeah, and then this is one of a good example and like evidence any kind of workload in the runtime can be changed or evolved in Serverless, and then along with your applications. So no more like just hello world or just RESTful API. The Kevin showcase, like an event-driven application could be running on Serverless and even AI workload as well.
Yep. All right, let's go back real quick to our VS Code here. Yes, I use VS Code in my case because I saw too many IntelliJ people. I wanted to spread the love a little bit. We can see here it built. So it did my native compilation here, a little bit up. And then we can see it here. There we go. Finished generating this camel demo ingester runner, which is in my target folder here. Where's the ingester project? Here it is. And then we can see here in the target. And then we have the camel demo ingester runner that was created, which is basically the binary of my jar. And then it didn't stop there. So it created the natively compiled application, and then ran, in this case, it noticed that I have Podman running on my local machine. So it did a container build with Podman to create the container image for me. And so it created, in this case, straight into OpenShift, camel demo ingester, and deployed it, or built it. Probably didn't deploy it. I could use Quarkus deploy to do that. And then my application would be deployed. And then let's see how the votes are going as well. And then we can wrap up the session because we're at the end of our time.
Oh, IntelliJ.
In this case, oh, yeah. So we have
3,000.
other who won. So I don't know if that's NetBeans.
Maybe what is the others?
Yeah, what is... let's see if the winner maybe created a little script, and maybe they can share that. If not, we can go back to the slides. NetBeans, nice.
Or some cloud ID, Depot.
Yeah, good old NetBeans. All right, so I'm going to go back to my slides. Sorry for clicking wildly. I can't keep track of which browser window. So finally, our serverless Java in action book is not available on developers.redhat.com. Hopefully soon, if we ever get to put the finishing touches on our book, but we are working hard on that. But then it will hopefully also be sponsored by Red Hat, like these books that you can download for free, which is always a nice thing. And then this is the link, or at least a QR code to the slides if you're interested in reviewing everything that we talked about, and our social. So if you want to connect with us on Blue Sky, we also post videos on YouTube about all this stuff. So feel free to follow us there. Any closing words, Daniel?
Pretty much good. Yeah. So Kevin and I, we're gonna keep doing this Quarkus journey, but also like AI stuff as well in many other in-person conference, for example, like a JFocus and DevNexus and VR developer and so on, and DevOps stuff as well. So if you have any chance to come to the JFocus in a couple of weeks in Stockholm, and then just you are very welcome to reach out to us and then say hello, and then join the workshop and then run some more interesting stuff as well.
And then we'll also be at DevNexus and at a few of the upcoming DevOxes and stuff like that. So, you'll find us if you go to a Java conference.
Yeah, absolutely. And then thank you so much for joining this session today. And then hopefully you enjoyed that demo and then learned something new. And then, yeah, looking forward to catching up in virtual and in person in coming soon.
Thank you.
You just finished in 1 hour. Couldn't be timed more
perfectly.
Perfect timing. Yeah, we always checking the time.
There were a few questions maybe that we can still show. Some guy named Kevin Dubois asked if there are Star Trek fans in the video. Because, yeah, we had that question. And then, if there are other frameworks doing the same kind of things. Some people mentioned Spring Cloud, Micronaut maybe. I don't know. Are there others?
No. Yeah.
Yeah, so I think the way that Quarkus does it with Funqy, I haven't seen that in other Java frameworks. But yeah, Spring Cloud Functions is the way to do functions with Spring. It's a little more convoluted than Quarkus, but of course, if you're in the Spring framework, that might be the best way to go. And I'm sure, yes, Micronaut also has some way of working with functions. You can find for each cloud provider, you can find documentation on their websites, but of course that's where you get to lock in with using their libraries, which again, it's not necessarily wrong. It's just that if you want to avoid the lock-in, then maybe that's something to keep in mind. But the alternative way is to use Knative, where you can create a container, and then it doesn't matter in which framework you're using, just as long as it runs and it starts up quickly, because that's kind of not a hard requirement for serverless, but it's definitely going to make your life easier.
Okay. And then one last question is, can we use a one-shot application? Should you do batch jobs with serverless? Is that a good idea? Is that a useful approach?
Yeah, I actually, there are some similar questions in the early. I actually answered that. So technically, you can define any trigger to point to your batch job as a serverless workload. And technically, you can do that. But however, so if you do batch job like a sort of a long learning process, like it takes maybe 30 minutes, 1 hour, or something like that, it significantly costs a lot of money. Like imagine that, like a Lambda or even Kubernetes. So yeah, Kevin, any?
Yeah, I was going to say, if you're going to use serverless functions for that on a cloud provider and it's a long running process, definitely that's not such a good idea. But what you could do is you could have a function that then perhaps delegates to a long running process. So that's definitely possible. Yeah. And then if you want to use Kubernetes and you have your own cluster, then then of course you can use Knative and you can have long running containers, because Knative doesn't have a limit of how long a function can run, whereas most of the cloud functions do have a fairly short limit of how long a function can run.
And then maybe small team, you're gonna maybe improve your batch job with Quarkus native and virtual thread, and among others.
Okay, good. I'm looking at the questions. No, that's it. So a few of the thank yous. So indeed, thanks a lot, both of you, for giving this presentation. Let me check what we have more. Yeah, so on check jchampionsconf.com for the full schedule with all the talks of today and the following days. So there are 5 more talks, 5 more sessions today. Tomorrow, next Monday and Tuesday, you can follow 7 more sessions per day. Let me take the opportunity to promote my own talk next Monday. I will be looking at music with Java, FX, and Kotlin, together with my son on the piano. But of course, there are a lot of more interesting sessions during all these days. Thank you, Daniel and Kevin, for your talk. Thank you all for watching. Have fun and enjoy the rest of the conference. Bye.
Bye. Thank you.
Thank you, Frank.